Hey everybody, this is Alex Merced from AlexMercedCoder.com, and in this video what I want to do is just kind of go over many of the fundamental sort of functional programming concepts and understand sort of like not only what they are, but like why do they matter. If you wanted to kind of practice more functional programming styles in your programming. Okay, so functional programming is just sort of a different paradigm when you think about like sort of how you write your code. So an optional in object-oriented programming, the idea is that you generally create these objects, and these objects generally have properties that you mutate. So the idea is that like, a dog's age increases, a kid may grow taller as they get older. So the idea is that the values actually mutate. Okay, and this is from a thinking point of view makes it easy to kind of think through how you create these abstractions because you're thinking about them as like sort of real life objects. And there's a lot of benefit to that, and for a lot of particular situations where you're solving certain problems, that may be a great approach. But there are things, optimizations you cannot do when you have sort of mutating data, and that's going to be sort of like the fundamental sort of insight here. So with functional programming, the idea is that data does not mutate, and this is going to enable lots of patterns that allow you to sort of optimize how your code is written to write less code and to reduce the amount of work that code does. Okay, so we'll just talk about a lot of this terminology, and first we'll talk about like what's a pure function. So I'll just create a new file. We'll call this like pure.js. Not to be confused with I think there's a library called pure.js, but that's not what this is. Okay, so the idea is, what is a pure function? Okay, a pure function has to meet certain criteria. One, doesn't mutate values outside of the function. Okay, and I'll show you an example. Okay, values outside of the function. It will, given the same inputs, okay, will return the same value. Okay, cool. Basically, generally those two things are true. Bottom line is that like it is sort of self-encapsulated. So bottom line, it relies on nothing externally. Okay, so if it doesn't have to rely on something existing outside of it to mutate, and it doesn't have to rely on something to figure out what it returns, then these two statements should be true. So let me show you an example of some impure functions. Number one. Okay, in this case, what it does, it mutates an outside value. Okay, so for example, if I wrote a function like this, I have a variable called let, count equal 1. And then I create a function, we'll call it like const increment count equals a function that just literally takes count plus equals 1. Okay. So now let's do this. I console.log count. Then we're going to increment count. Then, we'll just kind of do that a few times. Okay. Now, new terminal. Node pure.js. And see, like, the count goes up. Great. The problem is, this function depends on the existence of this variable outside of it. So what happens if I comment this out? Okay. And then I run that file again. See, I'm going to get an error. Okay, so this function is not self-encapsulated. It depends on the existence of something outside of it, which someone else who's using it may not have that existing outside of it. It may not be in scope for it to do its thing. So that can create sort of issues. Okay, so that's that example. So that's like a function that's not pure because it mutates something outside of itself. Okay, now let's do another example. Example number 2. Impure example number 2 doesn't necessarily return the same value. Okay, so now let's say we have like let num equal 1. Okay, and then we create a function that says function const plus 1 that equals a function that returns the value of num plus 1. Okay, or num plus, that takes an argument x and returns the value of num plus x. So we'll just call this plus x. Okay, so now if I run this function, okay, I say plus x 1, and then we want to console log that. Okay, so I'm not mutating the value. So again, I'm not mutating x. I'm not mutating num. I'm just returning num plus 1. So now if I run this twice, okay, if I run this, okay, I got the same result both times. So given the same input, I got the same output. But so you think, okay, that looks like a pure function. It, you know, it didn't mutate anything outside of it, and given the same value twice, it returned the same value twice. But now let's say I do this, num plus plus, and then I run this function again, 2 times. The second 2 times it gave me a different number. Okay, so because inside of this function we're referring to this variable num, this outside value, if that outside value changes, it can change with the return value of this function, even if you gave it the same argument. In this case, I gave it the argument of 1 all 4 times, but you know, 2 times it gave me the answer of 2, and 2 times it gave me the answer of 3. Okay, so in that case, the return value can be different. So the idea is, again, bottom line is you don't want the function inside to refer to things outside. Okay, so now let's give you an example of a pure function. Okay, pure function. Okay, so let's say do the same thing. So const plus x. Okay, and it's going to return you the result of taking a number and adding x to it. So it's going to take 2 arguments. Actually, let me fix that up a little bit. Take 2 arguments, the number and x, and returns num plus x. So it's returning you essentially the same thing, okay, but I'm asking for the number, okay? So now if I do this, console.log plus x 1, okay, and then 1, and I do that 2 times. And then I do, 2 and 1. I'm going to get the same console logs, but the difference is I'm giving it different arguments. Okay, no matter how many times if I say 1 and 1, it's always going to give me 1, and I give it 2 and 1. Okay, so in that case, if I want to get the same sort of effect as in the previous scenario, what I could do is I could still have let num equal 1, and then replace this with like num. Okay, and then still do like num plus plus here. I'm going to get the same result, but it's technically not getting the same argument every time. It's getting 2 different arguments. Okay. Cool. And again, this variable doesn't have to exist. It just has to be given that first argument. So the function is self-sufficient. It works by itself. Okay. This variable num doesn't have to exist. Okay, because it's expecting them to be passed in as an argument. Okay. And again, given the same 2 numbers, it's always going to give you the same result. Okay. So that's like the difference between an impure function and a pure function. Now, why do you care? Why would you want a pure function? I mean, there is the idea that it's kind of easier to predict. Like if you don't have these external things outside of the function that can affect how the function works, then it's going to be easier to predict, hey, what is this function going to give me? Okay, it makes it more predictable. But even more important is it allows you to do a technique called memoization. So that way you don't have to do the same calculation over and over again. So let's just do we'll just call this memo.js. Okay, and what memoization means is you cache calculations and use the cache if given this previously used arguments. Okay, so let's show you an example. So let's create that function again, const plus x, which takes num and x and returns num plus x. Okay, now if I wanted to memoize this function, so I want to basically say, hey, if I run this function twice and say 2 and 2 as my arguments, does it really need to calculate it twice? Maybe not. Okay, so what I can do is I can memoize the function. So we can create another function called const memo plus x, which is going to equal the same arguments, num x, except what it does, okay, this does is that it creates an object, so const cache equals an empty object. Okay, and then we need to change that to num and x. So we're going to have this object that's going to act as a cache. So the idea is going to track how many arguments have we passed in the past. So what it does is we're going to check to say, hey, does this object, have we received these arguments before? So what we're going to do is going to say if cache, and then we're going to use the square bracket notation because that's how we can dynamically access a property. We're going to say, hey, if num, we'll just say num dash x is in there. Just saying like that's like a property of those two arguments. So I'm saying, hey, is there a property in this object that already has that signifies that we've done this calculation before? If that's true, then we're just going to actually we want to wrap this in a function. So const memoized function equals num x. And then in here, we're running this logic. If x, because the idea is what you're doing is you're creating a memoized version of the function, where this function is not going to necessarily run plus x. It's going to run plus x if that version of plus x hasn't been run before. So it's going to be like if that property is in the cache, okay, then when do just so you can see it happen, console.log using cache. What it'll do is it'll just return the cached version. Return cache. So we'll just return that. Now, if it's not cached, what it's going to do is that it's going to say one cache. Again, it's going to then define this property, and it's going to define this property as the result of running plus x, passing in num and x. So the same num and x that we got from up here. In this case, up here. So actually, we don't really need this here, because technically this is going to handle that. Okay, so this is just going to create the memoize function. So actually, let's call this memoize plus x, and we'll just return that as memoize function. Okay, cache equals plus x num x, and then what it's going to do is then still return cache, that cached value now. Okay, in this case, we're going to say console log running the function fresh, just so that way you can see that which path it's going down. Running the function. Okay, so that's what this function is going to do. And then with this function, memoize plus x, returns that new function. Returns the memoized function, and now we can use that instead. So this seems like a lot of logic, and it is. Like that's like really complicated just to add a number. You wouldn't normally do this for adding a number. Imagine a calculation that's much more complicated, that every time you run the calculation might take like 10 seconds. Okay, having to do that calculation over and over again can really slow down your program. But if I can cache the answers and not recalculate that really, really long calculation, when I use numbers I've calculated before, that's where this becomes really useful. But I can't do this with an impure function, because with an impure function, there's no guarantee that the same inputs give you the same outputs. That's why you want a pure function, or else you can't memoize. Okay, so now I have the memoize function. Now let's actually watch it at work. So watch, if I do memoize, so now first we have to create the memoize function. So we're going to const memo plus x equals memoize what did we call the function here? Memoize plus x, yeah. Memoize plus x. Okay, because again, this function is going to return the memoize function. So this function memoize plus x memoizes plus the plus x function, and then and you could create a generic memoizing function. I've done it in a previous video, but here I'm kind of showing you what's going on. And that function is going to end up, that memoize function that gets created is going to get saved in here. Okay, so now if I use this console.log memo plus x, and I say, hey, 1, 1, and then I do it again with 2 and 1. Okay, let's see what we get. So node memo.js. Oop, I got an error. So let's see where the error was. Memo plus is not defined. Oh, I forgot the x's. Okay, let's run that. Okay, and see watch what happened. See, the first time we did 1 and 1, it ran the function. Okay, so then it saved that result of 2 in that object. Then on the second run, that property was already in the object, because again, it does that if statement over here. So let me just move that down. See, it does this if statement, and this time the property is defined. So instead of running the function and running the calculation again, it just returns the number that's already in the object. So if you had this, if this calculation took like 10 minutes before, it's only going to take a fraction of a second this time because the answer has already been pre-calculated. Okay, because since plus x is pure, given the same two arguments, it's always going to give you the same answer. So there's no need to recalculate it. So we have the answer saved because we've already calculated it before. Okay, and this allows you to save a lot of time. Okay, so that's what memoization is. So again, so far we've learned two things. One, I want pure functions. Why do I want pure functions? One reason is because I can speed up my programs because I can memorize those pure functions. Okay, but there's another reason we like pure functions is because we want to break down our logic into we want sort of composable functions. Instead of writing like, for example, composition.js. Okay, so for example, you might do some function that does like a bunch of different things. You're going to say, hey, you know, const, you know, modify string, and then it's going to take a string. Okay, oh, well, it's going to take in a string, and then you expect to, you know, take that, you know, you say, hey, I want to return, you know, say const reverse string. Okay, so then that's going to equal, we take the string and we turn it into an array. Oh, first we have to turn it into an array. So const string array equals the str.split, then we split it by letter. And then you want to reverse it, const reverse. Or actually string array dot reverse, string array dot reverse. Okay, and then what you want to do is you want to capitalize the letters, const capitalize equals you know, a string, the reverse string dot dot map, and then we want to take each letter and do an x2 uppercase. Okay, and that's going to return the array with all the letters uppercased. And then what we want to do is return the join string, capitalize, return capitalize, dot join, and then join each letter. Okay, and this will work. Okay, so for example, if I said, let's just try this out, console.log, modify string, hello. Okay, I should get a reverse version of hello that's all capitals. That's what I should get back. Node, well, now it's going to say hello, panel. Okay, node composition. And it works, okay? The problem is, now this function can only be used in one scenario. In the scenario where I need to split the string, reverse it, and then make it all capitals, okay? what would be more useful is to have functions that do each step. So that way I can reuse them, because sometimes I might just need the string as an array. Sometimes I might need, I might just need to reverse. So instead, I'd rather just have each one as an individual function that I can then put together. Okay. So for example, if I were to do that, okay, what I want to do is first create a, so again, if I think of each step, okay, I might first just want to take a, first we want to split the string, so we'll say const string 2 letters equals, and again, it's going to take the string and then return string dot split. Okay, and then that's all that function is going to do. The second step is we want to reverse it. So const reverse letters equals, again, it's going to take the letters, the array of letters, and then it's going to return letters dot reverse. Okay, even though reverse mutates the original, we're going to ignore that for a moment. Okay, and then we're going to const say, hey, next thing we want to do is capitalize. So we're going to say capitalize letters equals letters. So again, it's still an array of letters. It doesn't matter if it's reversed or not. And then what it does is it's going to return letters.map x, and then with each letter capitalized to uppercase. Okay, so that's what that function returns. Okay, and then what we want to do is we want to then, letters to a word. So const letters to word, okay, equals, you give it any array of letters, and it's going to return you letters dot join back to letter. So now what I do is I have a function for each step. And see, each of these functions is much simpler to read by itself because it's only doing one thing. Okay, but now if I want to do that same thing, it would just read like this. I want to take letters to word, because my end result is I want the word. But letters to word should be receiving the result of capitalized letters, so capitalized letters. And then capitalized letters should be receiving the result of reverse letters. And string to letter, and then that should be receiving the result of string to letters. And then again, that should be past the string that I want to reverse. Hello. Okay, and then I want to console log that so we can see the result. Okay, and again, these are probably simple enough operations that you probably, with the built-in functions in JavaScript, I probably didn't need to write individual functions for this. The function JavaScript already kind of gives you a lot of that sort of in these nice, useful bits. But just to kind of illustrate the point. And now when you're reading functions composed this way, I start from the inside and I work my way out, but it tells me a story. See, I take a string. I can tell that this string is going to take this string and turn it into letters. Okay, I know that this function is going to then reverse those letters. This function is going to then capitalize those letters. And then this is going to take those letters and turn them into a word. Okay, but now I don't have to capitalize the letters. I can, maybe there's a situation where I want to do reverse letters but not capitalize. I can still do that without having to write another function. So by creating that, by having function composition, by creating a lot of small functions that do a small step, okay, you can now have much more composable function. I'm not having to rewrite stuff as much. Okay, and then also my code is, even though it may look like, hey, like there's a lot of functions and functions, the function names help tell a story. Okay, and I can just start from here and I can get an idea of what is happening in this code, even if I don't know exactly how what's the implementation, what's the actual code inside these functions. I can get an idea of, hey, what's supposed to go in, because generally, like, we might all agree on the idea that letters means an array of one-letter strings, and then we understand word is the join of those letters. So I can kind of see here from, only thing I probably would have changed, just change this to word 2 letters, and so that way it semantically stays consistent. But you see the idea. So that's like function composition. So the idea is you write functions in a way that you can compose those functions, and you're going to maximize reusability of those functions. So that way you don't have to keep writing more functions. You can just reuse the same ones for different situations. And and you're going to have much more readable code. So even though like, hey, there's already a function for me to split a string here in JavaScript, I might want to still write this function that's, nice, encapsulates it in this one word just for the semantics in my code. Okay. So sometimes you might write a function that's like, hey, wait a second, I could have just done that without a function. I didn't need a separate function for that one step. But you may do it because, hey, this creates a nice semantic way for me to read the code. Okay, last topic, function currying. Okay, this is just another technique where, let's say I have a function that does a calculation. I'll say like, so we'll call this the uncurried function. And what this function does is it says like const, add x, y, z. Okay, and what it does, it takes given x, y, and z, it's going to return x, x plus y plus z. Okay. And this will work. This is a pure function, so technically it's memoizable, like it's fitting our story so far. Add x, y, z. 1, 2, 3, so that should equal 6. So if I run that, node curry.js. Oh, I spelled curry wrong. Okay, and duplicate parameter name not allowed. I wrote xyx. There we go. Okay, 6. Okay, so that returns the number 6. Wonderful. Okay, that is all fun and good. And this is fine. But what if you have a situation where I don't necessarily know x, y, and z up front? Okay, what would typically happen? Okay, you would have to kind of keep track of x, y, and z in variables, and then kind of hope that eventually in your program you have all three numbers and then run the function at that point. Okay, with the idea of currying is saying, hey, how about we just chop this up into functions that run as you get the information? Again, this can be useful for, like, for example, think of something like creating a user account, where basically the user is going to go through several steps filling out forms, and at the end you're going to have all the information you need to create that user account. So what you can do is, instead of saying, hey, you have to wait till you have all the information from the user and then running this function to create the user account, you can take those steps. And how would that look like? Okay, so let's do a curried function. The curried function is going to look very similar. So we're going to call this const, call it c add xyz, c for currying. Okay, equals. But instead what you do is at first the function starts out by just asking for x. But what it returns is a function that asks for y, which returns a function that asks for z, and then that function, okay, is what actually returns x plus y plus z. Okay, so you can imagine, like, you have a function that says first receives the username and then returns a function that asks for, like, the email, and then returns a function that, when that function is called, creates the user account. Okay, and again, this just allows you to sort of break up the function so you don't have to call it at one time, but you can. Like, if you do know all the information at one time, so if I can do console.log, c add xyz, I can still, do 1, except now I would do it like this, because what I'm doing is, this is me invoking the function as returned by the first function, because see, the first function asks for x, then that returns a function which I'm calling, which asks for y, and then that returns a function that I'm calling that asks for z. So I can use it the same way if I want. See, that still works. Okay, except now I do separate parentheses for each argument, but then I also have the flexibility of saying, hey, you know what? Let x, we'll say let x equal 1. Okay, and we'll just say const, just x equals c add xyz x. So right now, that's going to return me this function that's going to next want y. Okay, and then we're going to do is say, hey, const x and y, because now we're going to have x and y, And that's just going to be this function, because again, the result of that function that gets returned is now in here. So we'll say, hey, just x gets passed in, and we need to create a variable called y. So let's do that. Let y equal 2. Okay, so we'll say, hey, that equals y, and I could say then x and y, and then this is the final function. Okay, let z equal 3, and we'll say console.log x and y. I could have named those better. Z. So technically, this third function represents the function that asks for z, and that's the function that's actually going to return x plus y plus z. Okay. Okay, and then let's see what happened there. Oh, I already declared z before. What did I declare z? Oh, for some reason it decided node decided to voluntarily like require Zod on me. Okay. And you see, it still works. I still get 6. So even though I don't call it all, I'm just passing z. It's because technically it's passed this function returns this function, and technically each function has the parent function in its scope. So even though this function only receives z, it has this function and this function in its parent scope, so it has access to the y and it has access to x. So you can, say, hey, you know what, I'm going to give you the information in pieces, so that way I can give it to you as I get it to you in the right order, if you want, or basically make sure that, hey, these things happen in a certain order too. You can enforce a order, because I have to do the first function before I can get to the second function before I get to the third function, which is also, again, enforces, make sure that people have to do things in a certain order. But also makes it where I don't have to do it all at one time. I can incrementally do the calculation, and then once I have all the pieces, the final function will return me the result. Okay, that's referred to as function currying. And again, a lot of these things like memoization and currying are more useful in much more complex situations where you're doing a lot more steps and doing a lot of complex calculations. So you may want to, hey, you know what, instead of having one big function that takes 10 minutes to do a calculation, you may want to break it up into a bunch of smaller functions, so that way you can do other things in between them and break up that calculation so it doesn't stop your whole program immediately. You could also, use things like promises and, parallelization for that too. But, assuming we're trying to modify or optimize a single thread, things like memoization, things like currying can help you really kind of help space out when your code is doing what. Okay. So these are all functional programming concepts. But again, so notice how I haven't written one class. Everything has revolved around writing functions and using functions in ways that give me a little bit more mileage and make it where I don't have to rewrite. Because again, I might be able to, again, using this currying situation, I can then maybe use the intermediate functions as an input to another function at some point. There's different ways you can make that useful. So it just gives you more flexibility is the point. But with that, my name is Alex Merced from AlexMercedCoder.dev. Have a great day and enjoy. I'll see you all later. Have a great day and enjoy.